So we're getting started with chapter 10. In this video, we'll cover the entire chapter, and we're going to be talking about variables. And variables are usually what you think of when you think of algebra. And so before this chapter, we just sort of covered some basics of arithmetic mostly, different types of numbers, how to add, subtract, multiply, and some other operations. But now that we've covered all the basics, we're ready to start dealing in problems that involve variables. Or in other words, a variable is just basically a letter that represents a number. Okay, so if I give you the statement, an unknown number is larger than 5, you can probably come up with some possibilities for that particular number. A number that's first integer that's larger than 5, 6. Okay, or we could pick an even larger number. We could pick 10.32. We could pick a decimal number. Okay, we could pick 5.1, which isn't much larger, but still larger by 1/10. Okay. What are some numbers that the unknown number cannot be? Well, for one, it can't be negative. Okay, so we could pick any negative number that we wanted, and that's not larger than 5, so we could say -2. But there's even some positive numbers that aren't larger than 5. We could say +3. Okay, so down here below, what we're going to do is write a more algebraic mathematical statement to express this unknown number. Instead of using words to express a certain number, instead we use an inequality symbol. In this case, we say greater than, okay, which basically takes the place of these three words. Okay, is larger than. And most of the time we call this the greater than symbol. So likewise, we could say this means is greater than. Okay. Back up here in my blank, I also want to mention another number that is not larger than 5 that would probably be overlooked, is 5 itself. 5 is equal to 5, but 5 is not larger than 5. Okay, and with this inequality that we're using now, to show that 5 is not greater than 5, I can simply write a slash through it. Okay, and also at the same time, here we have the most important point about the translation of this statement is the phrase unknown number. Okay, in this case, x took the place of the unknown number. So we can literally walk through this entire phrase, replacing all of the words and keeping the numbers with more mathematical symbols. And x, in this case, is our variable. Okay, x equals an unknown number. Okay, so section 10.2, substitution. This just involves taking a general statement, usually in words, and replacing it with an algebraic expression that involves, in most cases, an equal sign, but as you saw before, we can use inequalities. Greater than, less than, okay, greater than, less than, greater than or equal to, less than or equal to, and also does not equal, and any of these others we can also put a slash through. And then since we mentioned does not equal, we should include equal to, but that was mentioned here in the reading of the chapter. Okay, so we have a question. It says find the value of 14 plus n when n equals 4. Okay, so here we have n equals 4. N is assigned to the number 4. Okay, so in this statement, anywhere we see an n, we are allowed to replace that with a number 4. Okay, so what we do is we simply write out our expression 14 plus n, and then we write an equal to, and we go off to the right, and we enter in 4. We drop the n, okay, we drop the n and we replace it with a 4, and so here we have 14 plus 4, and so likewise off to the side of 14 plus 4 we can put another equal sign and then an 18. So if I write it out all in one line, it would look like this with an 18 at the end. Okay, example 1, evaluating an algebraic expression, which is exactly what we just did. Okay, whole number addition and subtraction. So they give us this expression, b minus 5, and we want to evaluate that. Okay, well, we're told just immediately afterwards that b equals 14. So we can take this expression, write equal to, and in the place of b we write a 14, and so we're subtracting 5 from 14 and we get an 11. Okay, example 2. Here we have a variable multiplied by 5. Likewise, we could write m5, or we can write 5m, as we talked about in chapter 8. Okay, a lot of different ways you can express multiplication, but we are told that m equals 6. So we take this expression, or the original one, and we replace the m with the 6, and so I don't want to just simply write in a number, because that looks like 56. So when you have a variable, a lot of times you can just place them side by side with other variables or numbers. But when we have two numbers that are multiplied, we either want to use a dot, or we put a parentheses around one of the numbers to indicate that this isn't 56, we're multiplying 5 times 6. So to evaluate m times 5, with m being 6, we should get 30. Okay, example 3. Whole number operations with two operations. Evaluate the expression when a equals 81 and b equals 26. And so we see with this expression we have a b and an a. First, according to the order of operations, and we have, please excuse my dear Aunt Sally, we've got addition and we have division. So according to the order of operations, the first operation that we run into going from the top to the bottom is division. So whatever number a is, we need to divide that by 9 first. Okay. Alright, but what we can do is just simply substitute in our numbers for the variables. B is 26, so I write 26 plus A is 81, and I divide A by 9, and so I have 81 divided by 9. And as we just discussed, we should perform the division first. And so 81 divided by 9 would give us 9. And then adding 26 and 9, the only operation left is addition, we would get 35. So B plus A divided by 9 is 35 if A equals 81 and B equals 26. Okay. Example 4, we're given another expression, a little more complicated. We have several operations. We have multiplication, 3a, 2b, okay, and we have addition and subtraction on top, and then the top expression, 3a plus 2b minus 1. Once we've calculated that, we divide it by an a. Okay, so again, here are the order of operations. We don't have any grouping symbols, so parentheses is a no. And then exponents, we don't have to worry about those. But there's also an exception to a large fraction bar, in that we can carry out the operations on top and bottom separately. Okay, so I say first we just substitute in our numbers in the place of the variables. 3 times A would be converted to a 3 times 5. Then we have add 2 times B, and B is a 3. Replace B with 3, and then subtract 1. And on the bottom, whatever result we get from these operations on the top, in the end, we will divide it by 5. Okay, now just focusing on the numerator of this fraction, and here's our large fraction bar, we should do multiplication first. 3 times 5 is 15. This product and that product are separated by addition, so in the same step I can multiply 2 times 3 and get 6. And that's all I wanted to do in that step, so now I'll just simply fill in everything that I didn't use, minus 1, and then a 5 on the bottom. Okay, on the top, if I want to play it safe, I can add from left to right, and so 15 plus 6 would be a 21. And now again on the top, I want to perform all of the operations on the top before I try to divide by 5. 21 minus 1 would give us a 20. So I replace this with a 20, and finally I get 4. 5 goes into 24 times. Alright, in B we have a new expression. Division is separated from this product, and inside the product we have an exponent. The B is squared. Okay, and with the way this is written, only the B is squared. So let me just separate this from the rest of the expression. I want to point out that 3b squared can be written this way. 3 times b times another b. We just simply expand the exponent here for 2b's. Now, this is not the same. 3b squared is not the same as 3b squared with parentheses and the 3 and b inside. This expression would mean that I had 3b times another 3b, and 3 times 3 would give us 9b times b. So these are definitely different. This is a 3b times b. That is a 9 times b times b. Okay, so whenever exponents are involved, remember that parentheses make a difference. Okay. So I'll write down my expression first, and then I'll rewrite it, replacing a with 68. And our a and b now have new values. So a is divided by 4. I write 68 divided by 4. And then we have b squared, and so I'm going to write the 6, which is b equals 6. I'm going to write the 6 in parentheses with the 2 on the outside. And again, I did not involve the 3 with the exponent. Only the 6 is squared. Okay, 68 divided by 4 would give me 1, and then a 7. 17. And this piece and that piece, again, are separated by a plus, so one calculation over here doesn't affect a calculation there. And with this piece, I will calculate 6 squared first. Okay, and up at the top I can go off to the side and scribble down a 6 squared is 6 times 6. 2 6's multiplied, which gives me 36. That's where this came from. But the 6 squared is multiplied times 3, and so I have 3 times 36, which would be 90 plus 18, and that would be 108. And now finally I can perform the addition. 7 plus 8 is 15, so that'd be 115, and then plus the 10, so I get 125. Alright, new expression. We have 3 a plus b squared minus 5a, and now a is 7 and b is 1. So I'll keep everything the same, only replacing the variables. And a is just sitting next to the 5 with no mathematical symbols in between, but now I'm going to replace a with a number, and so I'll insert some parentheses so that this isn't misinterpreted as a 57. Now, I do have parentheses, so we follow our order of operations. Okay, so first I need to perform the operation inside the parentheses, and luckily there's only one, and so everything else I'll just bring it down around the parentheses, and 7 plus 1 on the inside is 8. Have a 3 outside, and then a 5 times 7 is subtracted from that. And I also have my squared. Okay, 8 squared. And so next I'm going to check off my exponent, which is the 2 here, and I have 3 times 8 times 8 is 64. So I'm taking it real slow and just doing one step at a time. Here I have two products, 3 times 64 and a 5 times a 7. I'll do those at the same time. Let's see, 3 times 60 would be 180, and 3 times 4 would be 12, and so when I add those together I would get 192. 3 times 64. Okay, and then we have subtract whatever I get from multiplying 5 and 7, which is 35. Okay, 192 minus 30 would be 162, and then I take 5 more and I come up with 157. Of course, you could always do the subtraction the traditional way. Borrow from the 9, this would become an 8, and that would now be a 12. Okay. 12 minus 5 is 7. 8 minus 3 is 5. And then there's a 0 here under the 1, so 1 minus 0, we just simply bring down the 1, so 157. D is b squared minus 2a over b, and a is 4 and b is 8, and I have a b squared. With this piece there's nothing else in front of it, and then behind it I have subtraction, so I'm just simply going to have an 8 squared there, and obviously the only thing the exponent 2 applies to is the 8. 2a, I'll use parentheses around the 4 when I replace the a. Again, I don't want to confuse that with 24, so I definitely want to put in some sort of symbol for some parentheses. And then on the bottom I have b, and I replace that with an 8. And the structure of this expression, we see that we have a large fraction bar separating the 8 from all of the operations on top, and so we'll leave the 8 alone for now and carry out all the operations on top. And once again we have our order PEMDAS. Please excuse my dear Aunt Sally. There are no grouping symbols. We do have these parentheses, but there's no operations to perform on the inside, so I can strike that out. But we do have the exponent, and so if I apply the exponent to the 8, which if I scribble out a calculation at the bottom for that, just to remind you that an 8 squared is just simply 2 8s multiplied, and 8 times 8 is 64. So I strike out the 8 squared and I replace it with the 64, and then I'll go ahead and multiply the 2 and the 4. Okay, this part and then this other part again are separated by subtraction, so I can calculate both without affecting the other. And so now all I have left to do on top is subtract. 64 minus 8 would be a 56. Now I divide 56 by 8 and I get a 7. Okay, so of course if I change the numbers a and b, I'd plug in different numbers into my expression, and I more than likely would get a different outcome. Okay, so depending on a and b, this expression b squared minus 2a divided by b, the value of that could change. Example 5, and let's see, evaluate the expression when b equals -3 and y equals 6. We have a y, and y is 6. The minus 5 is just a part of the expression, so I copy it out to the side of the 6. And now b is actually a negative number, and even if it wasn't a negative, I would still use parentheses, so I wouldn't confuse this with 53, but I think it's a good policy anytime you insert negative numbers into an expression and you want to evaluate it, you use parentheses. Okay, whether you're multiplying or adding or subtracting. Okay, so parentheses are also necessary because you don't want to misinterpret this as a 5 minus a 3, which if you didn't write the parentheses out it would look like that. 6 minus 5 minus 3. And that is not the same as 6 minus 5 times a negative 3. Does not equal. So what we're doing here is we're multiplying 5 times 3, and 5 has a negative, 3 has a negative, so we can apply the double negative rule here and say 5 times 3 is 15, and we'll make it a positive. Negative 5 times negative 3 is a positive 15, and now 6 plus 15 gives us a 21. Okay, moving on to 6, our last expression in this chapter. We have a 6 squared, and then we add 5 times c. Okay, or I should have said c squared. And then a minus 3 on the end. So, again, c is negative. So, every place that I replace c, I'm going to include parentheses. So a negative 6, this is c, and here c is squared, and so I'm going to put a square out to the side of the parentheses on the right, and I just simply copy over a 5, okay. Again, when I insert negative 6 for c, I'll put parentheses around it to show that we're not subtracting 6 from 5, we're multiplying it. And then we have minus 3. Okay, we can calculate negative 6 off to the side, or down at the bottom. This indicates that the negative and the 6 are squared, so I would write 2 negative 6's right beside each other. And now we apply the double negative rule. We count 2 negatives. 2 is even, and so my result of multiplication is going to be positive. And then a 6 times 6 is simply a 36. And I can drop the plus. 36 with no sign written is understood or assumed to be positive. So that takes care of that piece of the expression. This entire piece here gets replaced with a 36. Okay, then I can write plus, just bringing this plus down, and a 5 times a negative 6 I could write as a minus 30, and then I can write negative 3 off to the side. Alright, at the moment we only have 2 operations left. This is add, and here we are subtracting. Whenever addition and subtraction are mixed with no grouping symbols, I just simply work from left to right. And so I'm just going to look at this piece, first 2 numbers. And so 30, 36 plus a negative 30. Signs are different, so I'm subtracting the numbers. And so I get a 6. Okay, the number with the larger absolute value was a 36, and so the 6 is going to be positive. Okay. And now I just simply take the negative 3 and put it to the side of the 6. So this is 6 minus 3, which is positive 3. Okay, so there wasn't a whole lot of work to chapter 10, and it's not too difficult if you're careful about putting negative numbers inside of the expression, and of course replacing the variables with the right numbers if you have several different variables in an expression. And as always, the trick is to get plenty of practice, because anybody without practice can make some simple mistakes and miss some points on the test.